Okay, the following is a video for 11.2 notes, and this is areas of trapezoids, rhombi, and kites. So let's talk about the formulas real quick. The formula for the area of a trapezoid, this is a trapezoid here, is going to be the height divided by 2 times b sub 1 plus b sub 2. Okay, and let me label what these measurements are here. I'm going to call this length my base sub 1. This is my first base. I'm going to call this length down here b sub 2. That's my second base. And then I'm going to call the vertical distance from the very top of my figure to the bottom my height. Okay, so I would use this. Right? And these are formulas that we should memorize. All right, so I know that my height, so let's figure out this area real quick. My height is 1, 2, 3, 4. So I have 4 divided by 2 times b sub 1, which is 3, plus 1, 2, 3, 4, 5, 6, b sub 2, all right? And so I'm going to end up getting 4 divided by 2 is 2, times 3 plus 6, which is 9. So I know that my area is equal to 18 units squared, okay? And so that's my area for that. That's my formula. Okay, the area of a rhombus, let me change colors, of a rhombus is a little bit different, a little bit interesting. What we use is we use the diagonal. So I'm going to call this my diagonal, my first diagonal, d sub 1. I'm going to call my second diagonal d sub 2. Okay, and so I end up actually getting here that my area is equal to my first diagonal times my second diagonal. Okay, so my first diagonal was 4, so my area here is 4 times my horizontal diagonal, which is 6, and so I get that my area is equal to 24 units squared. All right. Now, this is kind of similar to what you would see for a parallelogram or rectangle, but what you get here when you split this up, when you connect the diagonals of a rhombus or a kite, you end up getting 4 triangles that, if you fit together, create what's it called? One of the creates a rectangle or a parallel or rectangle or a square, kind of depending on what you get. So that's why we use this formula. Now over here on a kite, we have something that's very similar. Okay, so for a kite, I'm going to take this diagonal length and this diagonal length. I'm going to call this d sub 1. I'm going to call this this one over here d sub 2. And I have the same formula here. I'm going to take my first diagonal times my second diagonal. So if I wanted to find my area, I would take my first diagonal, which is 4, and multiply it by my second diagonal, which is 5, and it's going to give me an area of 20 units squared. Okay, so those are my formulas that I want to use for this section. These need to be memorized, and they're pretty easy to memorize. So let's take a look at number 1. Okay, now I just want to plug this into my formula. Now my formula for the area of a trapezoid, area is equal to my height divided by 2 times the sum of my bases. So b sub 1 plus b sub 2. Now let's go over here and let's label this. Okay, this is my height, this is b sub 1, and this is b sub 2. So let's just plug these numbers into my formula. So we get my area is equal to 10 divided by 2 times b sub 1, which is 6, plus b sub 2, which is 15. All right, so now let's simplify this. I get 10 divided by 2, which is 5, times 6 plus 15, which is what, 21? And if I multiply 5 times 21, I'm going to get an area of 105 meters squared. Okay, so pretty easy, something that we should be able to do. Okay, let's take a look at number 2. Now I know that my area, this is a kite. All right, so my area of a kite is going to be the diagonal 1 times diagonal 2. So I'll call this diagonal 1, all right, and that's 14 millimeters. So I know that my area is going to be 14 times diagonal 2, which is a length of 12 millimeters. So if I take 14 times 12, that's going to give me 168 millimeters squared, and that's what I would do for that. Okay, just plug and chug. All right, number 3, last one. Now this one's a little bit different. Now this one's a rhombus. Okay, all these lengths, all the outside lengths are congruent, but I'm given that this length is 5. Okay, so if I know that this length is 5, let me change up my color. I know that this is also going to be 5 feet. If this length is 8 feet, I know that this length is also 8 feet, and I can just kind of tell by the picture. So if I called this my diagonal 1, my whole diagonal is the sum of these two parts, which is 16 feet. Okay, and I know that this diagonal, we'll call this d sub 2, that's going to be 5 and 5, which is 10 feet. So my area is d sub 1 times d sub 2, and so I end up getting 16 times 10. So I get an area of 160 feet squared, and that's the area on number 3. Okay, plug and chug. All right. All right, so look at number 4. Okay, now what it says is this is a little bit different. Okay, it says the trapezoid has base lengths of 6 and 15. The area is 136.5 square centimeters. What is the height of my trapezoid? So let's kind of draw a generic trapezoid here. All right, 6 and 15. That's good enough. Let me come over here, and I'm going to draw in my perpendicular line for my height. All right, I know that my base lengths are 6 and 15. Okay, now watch what happens here. All right, if I use my formula, area equals height divided by 2 times b sub 1 plus b sub 2, then I'm going to call this b sub 1, call this b sub 2. And I know that my area is 136.5. Okay, so I'm going to plug that in here, 136.5, and that's equal to my height divided by 2 times the sum of my bases. So 16 times 5, or I'm sorry, 6 plus 5, let's just write 6 plus 15, my bad. Write that in, and I get 136.5 is equal to my height divided by 2 times 6 plus 15, which is 21. And I'm going to put that over 1 here. Okay, so what I end up getting here is I get 136.5. Now watch what I do here. This is kind of not necessarily a trick, but it's just kind of how I work with fractions like this. If I take this, I'm multiplying my numerators and my denominators when I'm multiplying a fraction. So I can rewrite this as 21 times h divided by 2. Okay, this is an equivalent statement to this. Now, if I take 21 and divide that by 2, that's going to give me 10.5. Okay, so I can divide these out. If I'm multiplying, I can divide those. So I get 136.5 is equal to 10.5 times h. Okay, and I can divide by 10.5 on both sides. I'm going to divide by 10.5. And so this divides out, and I end up getting that h is equal to 136.5 divided by 10.5 actually gives me 13, and this is in centimeters. Okay, so, I'm not just plugging things in and hitting enter. I may plug things in and have to solve for one of these variables. Okay, and we just solve it like we would any other equation. Okay, these are cool problems. I like these ones. All right, let's look at another one. All right, it says one diagonal of a kite is 4 times as long as the other diagonal. The area of the kite is 72 square meters. What is the length of the diagonals? So this is another one of those kind of tricky problems. Let me draw some sort of. All right, let's just call this one diagonal. Okay, this is reasonable. All right, let's use red here. All right, I'm going to identify my diagonal. This is my horizontal diagonal, and this is my vertical diagonal. I'm going to call this d sub 1. I'm going to call this d sub 2. All right. I know that my area is equal to d sub 1 times d sub 2. So it says that one diagonal of the kite is 4 times as long as the other diagonal. Okay, now I don't know what either one of these are. Okay, but I'm going to call this diagonal here diagonal length x. So d sub 2, I'm going to label that as x. Now I'm going to call d sub 1. This is 4 times as long. I'm going to call this 4x, okay? And that's my d sub 1 value. All right, so that's something that we kind of got to get used to, is taking some words like this and being able to draw a picture, okay, and labeling what those are. So let's plug these in. Now I know I have an area of 72, so I'm going to take 72 and set that equal to d sub 1, which is 4x, and I'm going to multiply that by d sub 2, which is just x. Now, 72 is equal to, okay, if I take 4 times x, that means I'm taking 4 times x squared. Okay, and I can divide this by 4, and I can divide this by 4 and solve for x. So 72 divided by 4 ends up giving me 18. So 18 is equal to x squared, and from here I can take the square root of both sides, and I end up getting that x is equal to the square root of 18. Now you can simplify this to, um, oh, what is it? 2 times the square root of, no, sorry, 3 times the square root of 2. All right. And I get that by splitting this up into the square root of 9 times the square root of 2. And so this gives me 3 times the square root of 2. That's length x. So I'm trying to find the diagonals. What are the lengths of the diagonals? So I know that d sub 2 is equal to x. Well, x is just 3 root 2. So I know that d sub 2 is 3 times the square root of 2. Okay, and I know that d sub 1 is equal to x times 4, 4x. So I can do this. Let me write 4 times x. I can reorder these using the commutative property. And I can take 4 times 3 times the square root of 2, and 4 times 3 ends up giving me 12. So I get 12 square root of 2. And what's my label on these? These are meters. So d sub 2 is 3 root 2 meters. And then I know that d sub 1 is um, 12 square root of 2 meters. Okay. All right, one more. All right. You guys are doing great. Okay, a trapezoid has a height of 24 meters and a base of 4 meters, an area of 264. What is the length of the other base? So let's draw a generic trapezoid here. And we just kind of want to use this to help us fill in what we need to find our missing variable here. So this is my height. Okay, it makes a right angle. I'm going to call this b sub 1, call this b sub 2. My area is equal to my height divided by 2 times b sub 1 plus b sub 2. Okay, now my area is 264. Gives me that. So this is 264. Now the height gives me 24 meters. Okay, and a base of 4 meters. I'll call this one 4 meters. And so this is the base that we don't know. Okay, we're trying to find this one. So let's plug our values in. So for height, I want to plug in 24. All right, so 24 divided by 2 times b sub 1, which is 4, plus b sub 2. And that's what we're trying to find, is b sub 2. Solve for that. Okay, I can simplify 24 over 2. I get 264 is equal to 12 times 4 plus b sub 2. There's a number of ways to solve this, guys. I think one of the ways, let's just go ahead and distribute this 12 here. And so we have 264 is equal to 12 times 4 is 48 plus 12b sub 2. Okay, I can subtract 48 from both sides. And I end up getting, what do I get here? 216 is equal to 12 times b sub 2. All right, and so then if I divide this by 12, and by 12, I end up getting that b sub 2 is equal to 18, and this is in meters. Okay, so we're just using formulas. This should be something that we should be able to do. Please get started on your 11.2 homework. Thank you.